and I'm only going to really be talking about one of those. And I think the difficulty of achieving alignment does depend on how you define alignment, and you're going to find people that really disagree on this concept. So I'm not saying other people who would say vehemently define alignment as very separate from the governance or the non-technical issues. I'm not saying that group of people are wrong. This is just one perspective on how I think alignment has evolved over the past decade. So in terms of today's talk, I'm going to start by aligning a bit on the alignment problem. So that's essentially what has been the transition of this term over the past decade, and how has this term grown, or how does it need to grow to adapt to today's world. I'm also going to cover a bit of work that we've done in the past, talking about how different people in academia and industry have operationalized alignment before. And then I'm going to cover the main brunt of the work I've been doing, which is an empirical approach to defining alignment, which is to ask lots of people around the world which behaviors they think are important for alignment. And then lastly, I'm going to cover some takeaways from that empirical project of what tensions remain in alignment today. And at the end, lots of time for discussions and questions on what you all think alignment means and how we can come to an agreement as a community on how we progress with this rather thorny term. Okay, so in terms of the origins of the alignment problem, where have we come from? Well, I want to start by telling a little story. So this story starts with two characters. We have H, which stands for human, and we have R, which stands for this robotic arm. And H and R have an important task to complete together. They either eat cake or they face certain death. And this seems quite silly, but this is very much the operationalization of alignment from the early days. This is the tale of alignment in the Berkeley Chi lab, Stuart Russell's lab, from around the mid-2010s. And this is a figure from one of the papers from that lab in 2017. And it's all about human preference learning in this very narrow setting of how do we get one human operator to communicate their preferences to one robotic arm. So in this specification, it's very much a one-to-one operator intent alignment. And in this setting, it led to the kind of dominance of inverse reinforcement learning and cooperative inverse reinforcement learning, which can broadly or is broadly described by Stuart Russell as the machine's only objective is to maximize the realization of human preferences. The machine is initially uncertain about what those preferences are, so the ultimate source of information about human preferences is human behavior. So we kind of have this iterative relationship between the human operator and the robotic arm to try and infer the preferences between, in this case, cake and poison, so that the robotic arm can carry out those actions in an obedient way. You might already be noticing a tension here, that the whole reason that we use inverse reinforcement learning is because we acknowledge that specifying what we want as humans is incredibly hard to do. This is like the classic Midas touch fable of it's very, very hard to say what we want and to include all of the different nuances in a single statement or definition. And because it's so hard to specify human reward functions, we use reward modeling instead. So it's some kind of observation or interaction with a human operator that reveals their rewards about an environment. But we still have incredibly restrictive assumptions about how humans function. So for example, that they can actually know what they want internally, that those preferences are stable over time. Assumptions like that have been shown to not be true with humans. Okay, so what factors then about what we know about human and AI behavior and organization might inform a more nuanced treatment of alignment in today's landscape, or at least convince us how this term alignment, as it was initially conceived as a one-to-one operator intent alignment, how that might need readdressing given the complexities of the world that we live in today. So one of the first changes is just an explosion in H. So according to recent ChatGPT figures, we have over 180 million human operators now, at least, because that's just for ChatGPT. And these human operators are no longer in that Berkeley lab training that single robot. They're situated all over the world. They hold different ideologies. They speak different languages. They have been conditioned by lived experiences in different cultures, and they use LLMs or AI systems for very, very different things, and they act in so many different professions. So essentially, we have an explosion in human operators that vary on many observable or socio-demographic characteristics, but they also vary on unobservable factors too. This is a complex dynamic of human operators now. We've also had an explosion and an evolution of this character R. So R is no longer a robotic arm. R is now a steerable general purpose agent that can communicate with us in natural language, which really moves the goalposts for alignment. And it can also act as a wrapper for tools. More and more, we're seeing LLMs being used as agents. So that's why I've included this little black arrow here between the LLM icon and the robotic arm, because more and more we're seeing LLMs as tool users. And there's been a huge proliferation in access to models. So there's over 350,000 models now on the Hugging Face Hub, which can be downloaded at the click of a button. And those have very varied degrees of alignment post-tuning. So there's been much greater diversity in the models that are actually available to people nowadays. So yes, you can get Llama 3 or Llama 2. But you can also get a version of the model that hasn't been alignment fine-tuned or doesn't have much safety fine-tuning. So there's just a much wider buffet of the models that are available now. And even within one model, given the greater steerability of AI systems nowadays, it's possible to elicit many, many personas within each model. So we're just getting a lot more diversity in the types of personalities or alignment positions you can even get within one model. And that begs the question of what does it mean anymore to have this a one-to-one relationship, given that a model can actually possess many different kind of underlying personas. So even though we have these many H's and many R's now in today's story, in reality, what we see is a power concentration. So in a recent paper that I actually wrote with Kaylin here, we look at the distribution of models on the Hugging Face Hub and find that very small number of models contribute to the mass volume of activity. So there's very much a power law in how few models are taking up most of the demand in the AI ecosystem. And this is, of course, true of the commercial models as well. A lot more people, a lot more traffic gets routed to the ChatGPT API and interface than it does to a small model on Hugging Face. So even though we have a lot of models, we actually have multiple people using the same model. So again, it calls into question how this kind of one-to-one intent operator definition of alignment functions in this much more complicated ecosystem. And to add fuel to the fire, this is even more complicated because we kind of have a meta operator here, which are the companies that are producing and controlling these systems. OpenAI is acting as kind of the middleman between the human operators and the R, or the system in this case. And they're trying to essentially estimate the preferences of lots and lots of people and their own preferences as well as a corporation. And this means there's kind of many more removed chains of command from how it was in the Berkeley days of an individual operator operating an individual robotic arm. So things are a lot more complicated. And in this dynamic, in the past couple years, what we've seen is majority of traffic from many more humans going to a few kind of big models. Maybe we get some traffic coming through to the open source community, but broadly there's been kind of less personal shifts in the past 15 years. So we went from this one-to-one single human, single model, and it's much harder to take that definition into the way that AI is embedded in our world today. But I have cause to believe that actually what's going to happen over the next decade or the next 15 years is that AI systems might start to get more personal again. Maybe we'll go back to this kind of one-to-one relationship a little bit more. And this is kind of evidenced by announcements like Apple are going to start putting kind of on-device assistance on people's phones. That's already starting to create a more one-to-one relationship with an assistant. And there's been many trends towards personalized AI and personalized LLMs, both from commercial providers and in the open source ecosystem too. So we've kind of expanded out to many people now using LLMs, many real humans using real models, and that might collapse in. But I think the point to make here is that alignment is no longer hypothetical. It's no longer within the confines of a Berkeley lab. This is something where real people are using real models, and how those models display certain behaviors, how obediently they follow certain specifications, what specifications are kind of illegitimate and legitimate. These are questions that we need to start asking today. So one of the things that I'm really interested in my body of PhD research is how can we answer this question empirically? How can empirical methods of human feedback help us understand what it means for an LLM to be aligned, especially when we open up this kind of definitional power to the perspective of diverse humans from around the world? So the main thing I'm going to talk about today is this new data set of human feedback, which is kind of like a heavily empiricist approach to alignment. But it also builds on these two pieces of conceptual work, which I'll cover briefly at the beginning. All these papers are online. The data set is also already online if you want to start using it. But yeah, you should be able to find all of these online. So just to start, we kind of grounded this work in a semi-systematic literature review of how human feedback has been integrated into large language models in the past. So pre-LLM era, we looked at the trends. There's actually a longer history than you might imagine of natural language, human feedback, and reinforcement learning for a variety of NLP tasks like machine translation, but also dialogue. So we looked at this kind of pre-LLM trend, and then we shifted into in current practices of using human feedback in LLM systems. How are people first motivating the use of human feedback, and why are they collecting feedback in the first place? And then what methods are they using to integrate that human feedback into the LLM system, which includes how is feedback collected? Is it ratings? Is it demonstration? Is it natural language? Who is that feedback collected from? Was it the authors that did the brunt of the work? Was it the crowd? Was it crowd workers? How many people were included in these feedback protocols? And then how was it actually integrated into the model? So this is things like, was it preference pre-training? Was it supervised fine-tuning? Was it kind of classic RLHF pipelines? This work was published in EMNLP last year. It's already horrendously out of date given how fast the AI kind of environment moves. So I think once we got it published, we have a comment in our limitations of like, all of this stuff came out since whilst we were under peer review. So there was like DPO and all of these new techniques all came out a couple weeks after this went into an anonymity period. So it is a bit out of date, but hopefully the general kind of thematic conclusions apply of why do people collect feedback in the first place, and what's the broad ecosystem for collecting that feedback. And using this, we come up with a number of challenges that were shared across papers that we read, and provide some recommendations for how these can be improved in the future. So the ones I'm mainly going to focus on today is the challenging the assumption that preferences and values are universal, and actually we see a lot of human diversity in how people hold and form preferences and values. And we argue to try and more transparently communicate what you mean by preferences and values to avoid empty signifiers, which I will come back to in a couple of slides. We also try to seek clearer definitions of actually what are we aligning to. Is it preferences? Is it intent? Is it values? There are subtle differences between these things. And finally, that it's very hard to operationalize what good means. So who's in the driver's seat then matters very much, because what a good output is ends up being very subjective. So we try and encourage also being very, very prescriptive, very, very transparent about the setup of the task, how annotators were recruited, annotated demographics, whatsoever, so that we can document the biases in the workforce. So this second paper, also a conceptual paper, kind of builds on some of those recommendations. So it does a bit more of a detailed review of data sets and guidelines in empirical alignment artifacts to work out what are their commonalities. And broadly, we use this post-structuralist political theory from Ernesto Laclau about empty signifiers. Now, empty signifiers were first used to refer to terms like democracy or freedom, things that we can all agree seem like a very good thing in practice. I think alignment is one of these things. It seems like a great thing to have models aligned to the values of the human species. But once you start actually moving away from this very abstract, hand-wavy and vague conceptualization of a term, and you have to operationalize that into a model or a data set, we can no longer exist in this very vague setting. And this is what Ernesto Lacau also found with empty signifiers. Everyone can agree that democracy is a good thing, but if you ask 100 people on the street what democracy means, you'll get 100 different answers. And like I said, this is only sustainable in the abstract. So when we actually are trying to use empirical artifacts to align LLMs, we need some form of measurable signal. And to have some form of measurable signal, we have to start to kind of codify what behaviors and what definitions of those behaviors we're going to put into our data sets and our models. And this is the framework we come up with. We situate a lot of existing research onto these two axes. And broadly, the axes cover dimensions. So what behaviors are considered in scope for a model to be aligned. You find some specifications that leave this incredibly broad and just say, we're targeting good outputs or better outputs. And then you find other practitioners who really, really target specific behavioral attributes. So Anthropic is probably the best example of this. They target helpfulness, honesty, and harmlessness as like these characteristics that a model must possess if it's going to be aligned. Then the second axis is how are these dimensions actually defined and who is doing the defining. So a good example of this is Google in one of their, in the Lambda paper, they target safety as a property of the model. And they're very clear in saying, by safety, we mean Google's organizational principles according to safety. Here are those principles. So that's a very good example of where it's very clearly defined according to organizational principles. In other settings, for example, the Anthropic data sets, even though they define that HHH is like the paradigm they want to be in, they leave it very open to subjective interpretation of the crowd workers. So they don't actually provide a definition of what they mean by honesty or what they mean by helpfulness. So you get a kind of variety across the literature where people sit on these axes of kind of how prescriptive are they, how specific are they, etc. And the data set I'm going to talk about today is kind of right in the bottom corner. We really wanted to measure the degree of kind of subjective disagreement. And in order to do that, you have to throw kind of all the guidelines to the wayside. Like you can no longer say like, okay, you need to rate this output for helpfulness, because you're then inherently assuming that people want helpful language models, which if you hadn't told them that might not be true. So we try and throw away kind of any of those prescriptive guidelines and really focus on measuring how much do different humans disagree. So this brings me on to PRISM, which the TLDR is that it's a large scale data set. The data set was kind of the primary contribution. It's out there today. You can use it for lots of things. We also do demonstrate a couple ways to use it through some experiments and some case studies, just to kind of ground the types of things you can do with the data set. So PRISM at a glance, like one of the most important things to know about PRISM is that it consists of a survey and some live conversations. And to my knowledge, I think it's the first large-scale data set to kind of link those two things up. And broadly, those two things rely on both the ask and the observe principles of social science. So what we do is we first recruit participants across the globe. We had very grand aims for this study to recruit people in lots of languages across like every country. In the end, we were somewhat limited by the pool of crowd workers that we had access to. And we do have some sampling aims towards also getting representative samples. At the beginning, we wanted as representative samples as possible in all the countries we sampled from. But in the end, representative samples, by representative, I mean sampled in accordance to census proportions, were only available in the US and the UK. So that's why our sample as a whole is skewed towards those countries which are already quite represented in AI research. But it's so we can get the depth of demographics there. And then in the other regions, most regions are still dominated by one or two countries, but compared to prior work, we have a pretty good spread. I mean, actually, Aya, the data set from Cohere for AI was an amazing, amazing effort, and they do a lot more groundwork than we do in sampling kind of hard to sample communities across different languages. But certainly compared to a lot of human preference data out there, we have a lot more geographic diversity. So after we've sampled people, they come and do a very, very detailed survey. I'll give you some insight into what that survey contains in a second. And then almost everyone, after they finish the survey, goes on to the second stage, which was hosted on Dynabench in a custom interface where these participants interact with models in real time and give us very rich data on their preferences. And how this works is I arrive at the platform, I put in a prompt of my choice. We have a pool of around 20 LLMs in the back end. And when I send my prompt, we randomly select 4 of those LLMs. And those are the 4 that respond to my prompt. I then rate all those 4 LLMs, and whichever one was the highest rated is now kind of locked into the conversation. So you can see here in the second, the third, and fourth, and so on, all of the subsequent turns of conversation, you can see that it's the same copy of one LLM. Sorry, 2 copies of one LLM. So essentially we have an A and a B. This is underneath, it's the same Cohere command model, just sampled at a non-deterministic temperature. So as we move from kind of the 4 model setting to the 1 model setting, we get like much narrower outputs and a much narrower distribution of score. And then after they finish the conversation, they give some fine-grained feedback. And each individual did around 6 of these full threads of conversation. So overall, at a glance, this is a fairly large data set. We had 1,500 people complete the survey, and almost all of them went through to have conversations with language models as well. These people were born in 75 countries and lived in around 40 countries. The LLMs that we had in the back end consisted of 20 to 21 different LLMs. Around 50% were open source, around 50% were commercial. And kind of the interaction of all these people speaking to all of these LLMs resulted in just over 8,000 kind of full conversational trees, and just under 70,000 of what we call utterances, which is a human message met with a model response associated with a score. Okay, so digging into a bit more detail into what the data set actually contains at a fine-grained level, we have very detailed stated preferences. So one of the cool things about this data set is you can approach alignment techniques that rely either on stated preferences like constitutional AI, or you can approach alignment techniques that rely more on revealed preferences, or what we call contextual preferences, which would be like more the RLHF style of do you prefer output A or output B. But in the survey, we collect these stated preferences. So we have a system string, kind of a la the constitutional AI framework. And just to give you kind of a flavor of what these system strings contained, people really went to town and put a lot of effort into what they were writing here. And you can see that we already are seeing disagreements or inconsistencies or ways that we couldn't really train one AI system to resolve both of these system strings at once. And in the paper, we have a pretty detailed overview of like the types of words and some common phrases that came out in the system strings as well. As well as this kind of unstructured format of stated preference, we also collect structured ratings of fine-grained attributes. So all of this happens in the survey before they've actually interacted with any language models. And we collect these stated preferences over 7 different dimensions, where each individual is essentially rating statements like, I think it's important that a language model is fluent. I think it's important that a language model is safe, with these specific statements. And we collect all of this. And there were actually some interesting takeaways from this question. So I think what's really interesting here is there are some slightly more kind of objective attributes like helpfulness, fluency, factuality, maybe the harder attributes. And then there's some slightly more subjective or softer attributes like diversity, creativity, personalization, and values. And we really see a difference in distribution here. So the more objective ones are very bunched up towards 100. So most people thought those were very important. Worth noting, this wasn't like a budgeted exercise. So saying that one thing was really important didn't mean that you had to make a judgment on something being less important. You technically could have said all of them were 100 out of 100. But on these more subjective measures, we have a much more spread out distribution. And I think it's really interesting how when we look at the values question, that's like very spread out. So what that tells us is that people, at least in how we specified it in our questionnaire, can't even agree at meta level whether value alignment is an important property for a model to have, at least from how they interpreted our question. We also, alongside these stated preferences, collect a ton of information on each participant. So lots and lots of demographics, lots of information on how they use LLMs, how often, how familiar they are. We collect a self-described profile, which is just them writing in their own words who they are and what they care about. And then we also collect kind of their geographical data too. So on to the conversations. When they arrive at our platform after completing this very detailed survey, they choose 3 different types of conversation that they can have. And we ask each participant to do 2 of each type. And the reason we included this is to basically avoid the situation where everyone like starts the conversation with, hey, how are you? Or what's the weather like today? Or something like very generic and bland. I'd really recommend, if anyone else is doing kind of large scale crowdsourced efforts, that this type of prompting at the beginning can be a good way to nudge someone towards diversity without actually specifying exactly what they have to talk about. And we did actually find that these 3 different settings, which is kind of an unguided baseline and something neutral, we let them have a free choice there. A values guided baseline, which was usually something to do with work, religion, family, politics, or culture, and this controversy guided setting, which was something that people would disagree about in a culture, community, or country. This did actually really work to prime different conversations. So this is a representation of some topics that emerged from the data, and you can start to see there are some really interesting clusters of discussion here where we would expect there to be a lot of interpersonal and cross-cultural disagreement. So we have a cluster on the Israel-Palestine conflict, we have a cluster on discussions on abortion. We also have some value-centric things like religion, gun rights, etc. And also these are combined with more neutral or unguided baseline topics like weather inquiries, recipes, travel recommendations. So there really is a lot of variation along the subjective kind of objective spectrum, which I think could make some really interesting questions in future work. So just to give you an overview of what the interface looks like when they have arrived at our interface and chosen what type of conversation they're logging, you can see here, this is probably the unguided one. Tell me a one-liner joke about artificial intelligence. As I explained before in the high-level summary, they get 4 different responses back, and then they rate. I think we're good. They rate these responses on a visual analog scale, which is this very fluid measure of collecting subjective preferences that aims to avoid anchoring biases and dependency biases across different vignettes. So here you can see there's the 4 different responses, and they rate all of them from terrible to perfect. And then whichever one was rated highest kind of stays in the loop as the conversation as the conversational partner, and then they can continue the conversation for as many more turns as they like. We enforced that they had to go at least 1 more turn into the conversation, but it went all the way up to 22 turns. And again, they do the same exercise that they get these 2 responses, much more similar now because they're sampled from the same model. But again, they rate them from terrible to perfect. And we did actually see a much narrower score distribution here. And in addition to the preferences in the conversation, we collect fine-grained feedback after the conversation has ended. And these are exactly the same attributes that we collected in the survey. So essentially, you should be able to map across how people's kind of global stated preferences, how those shift in local in situ contexts, which was one of the design features we wanted to include in this data set. And finally, as well, in the conversations, after they finish all of these ratings and interactions, we asked them to give some free text feedback on each conversation. And once again, people really put in a lot of effort here. So some people wrote like mini essays on exactly why they thought the LLM was fantastic or terrible, or all the moral features of their conversation. So this one I quite like. This one really stressed the AI's little brain to the max, which I think is quite a funny quote. Again, in the paper, somewhere in the appendix, you can find an overview of what was contained in these free text responses. But we hope also that people could use this to basically like train a reward model using natural language feedback as well. Oh, okay. So a bit of a break there because I realized that was probably a lot to take in. I think the main thing that we really wanted with this data set is to provide a new resource to the community that could be used to answer a whole host of empirical alignment questions. So we're really excited to see what people do with all of the richness that we designed there to be. So just some overviews of what we found before I wrap up for today. Firstly, we did find, we did do some investigations on whether identity or socio-demographic conditions the types of conversations that people have with LLMs. So we take all of these different identity attributes, which you can see in the bar charts at the top here. And this also gives you an idea of the distribution of this is our whole data set. And then we take all of the topics, which I showed you on the cluster chart before, which are all of the different things that people talk to LLMs about once it comes through our clustering pipeline. And then we run a regression to look at the impact of identity on topic prevalence. So based on all of these different attributes, how likely is it that they contribute to that topic being discussed by a particular participant? And this is probably way too information dense for you to take in, but just a couple of takeaways from the top of my head. We did find some kind of salient associations between identity and topic. So for example, female participants and non-binary participants were much more likely to talk about gender and LGBTQ issues more than men. We found that older people were more likely to talk about elections and younger people were more likely to talk about job search. We found this kind of multicollinearity effect between ethnicity, religion, and location to do with the Israel-Palestine conflict. And I think that's broadly also because of our kind of sample biases too. And we also found, I think, almost every location, so every geography of participant talked about abortion less than US participants. So there definitely are some of these like salient associations between identity and dialogue. But actually in the paper, we run this second analysis where we look at really granular kind of local neighborhoods of discussion. So for example, we take the prompt, does God exist? And we find all of the semantic neighbors, the very close neighbors around that prompt. So only small variations in syntax or semantics. And in these very, very tightly clustered discursive spaces, we find actually that there's lots of intersectional diversity in the authors of those prompts. So this cluster of people talking about whether God exists, you have representation from almost every location, you have loads of different ethnicities, you have kind of 50% of people are religious, 50% of people are not religious. So the main takeaway actually is that people kind of share these issue spaces, which I think is a really interesting feature of the data set, because it means if you're trying to investigate kind of diversity of participant perspective, you have these anchors of people discussing similar things. So given that we know that people discuss and share kind of similar things depending on their identity, bar some kind of particularly salient factors, we then look into how different people and different groups prefer differently aligned models. Now, we don't actually do any training in this paper. We just use differently aligned models to be the models that were included in our experiment, kind of off the shelf. And you can see here on the y-axis the different models that were included in our experiment. And we do this, this thought experiment of what would happen if we had sampled different people, collected their preferences, and then calculated model ranks or model scores. And we choose 100 people just because a lot of the literature that I've reviewed before, albeit maybe slightly out-of-date literature now, was using fairly small samples of humans to give human feedback or also to run human eval experiments. And what you can see here from this exercise, if we sample 100 people lots and lots of times, so we run a bootstrapping exercise, you can see that there's a fair amount of idiosyncratic variation in how people prefer models. So we see, especially in the middle region of these ranks, that there could be a lot of movement in the final ranking of the model, depending on which humans are included in the sample. The second exercise we look at is not just sampling kind of randomly from our data set, but actually what if we did kind of purposeful sampling only from certain groups. So how would our picture of model ranks, how would our perception of which models are better than others? Model ranks and benchmarks are obviously a huge thing now with, you know, chatbot arena and all of these things. So how would our perception of pairwise win rates and pairwise battles change depending on which individuals we included in the sample? So again, probably too information rich for you to take in today, but I think the main thing, without looking at this in more detail in the paper, that you should take away from today is just that there's a lot of movement in model ranks depending on which kind of group we sample. So models rise and fall, you know, up to I think 7 or 8 spots, depending on which geography of participants you're including in the sample. And I think that demonstrates to us that a lot of the kind of the clearly defined model ranks that we see in other benchmarks or other settings might actually be quite vulnerable to noise if different people had been included in those kind of feedback sessions. The very last thought experiment we do is kind of, why does this matter? Why does it matter that people like different LLMs? Well, the reason it matters is precisely because not everyone is going to be asked to contribute to a feedback process. So when we're collecting human feedback, only some humans are going to be asked to contribute their feedback. And those humans are going to be sampled from a wider population of LLM users. So we ask the question here where we run the thought experiment of what would happen if we only sampled certain groups. We don't actually train any LLMs in this exercise. It's just kind of a thought experiment. And the way we run that thought experiment is, you can see the groups here on the y-axis. We put these groups in the seat of power. So we either take a representative sample of various ends. So we have 10 people, 20 people, 50 people, 100 people, or we take a non-representative sample, which is heavily biased or actually exclusive to only one kind of segment of demographic. And we do this for the US representative sample. So we take this group who are in the seat of power, we work out what their favorite LLM is as a group, and then we apply that LLM to all the other people in the population that weren't asked during the feedback protocol. Obviously here, it's not that they're not being asked, they're just being excluded from the sample when we're calculating it. And we find some interesting things. So quite intuitively, we find that larger samples are better. So we can see the distribution of welfare in a population is like more bunched to the right, which means it's better when we take a sample of 100 people versus 10 people. So in this setting, what we're doing is we're calculating the welfare for the population as a whole. So we're taking it just from a sample of 10, and then we're applying that at chosen LLM to everyone else. We also find quite intuitively that a more representative sample tends to be better. So sampling from 100 representative individuals and applying that chosen LLM to the population at large tends to make people better off. They have better end preferences for that LLM that was chosen compared to sampling only men. And in some cases, these non-representative samples can actually look better for the majority group. So you can see here that when we sample 100 white individuals from the US, take their aggregate chosen LLM and apply it to everyone else, that looks like it's better. But there's a caveat here, and this is because the US population obviously is not uniformly balanced by different ethnicities. So when we take this LLM that was chosen by the sample that was only white participants, it can harm the welfare, especially of minority groups. So we see here that actually is definitely not the best choice for the non-white participants in our experiment. So what this demonstrates kind of at quite an abstract level is just who you're including in these feedback processes probably does influence the people that are then subjected to how that model has been trained in the future. But we really do encourage kind of more ecologically valid experiments on this in the future. Okay, so what were the main takeaways of what we actually learned from PRISM? At a high level, there were tons of things that were really interesting, but I think 2 things really stood out to me. So one is that my revealed short-term preferences as an individual might not be in my long-term interest. Now, this might sound paternalistic to you, it might sound protective, but just to illustrate with a couple examples, we found many people wanted a model that was anthropomorphic. So they wanted a model that sounded human. They wanted a model that was chatty and engaging. And that might seem like a really good thing at first, to have like a closer interpersonal relationship with an AI assistant, say, but it might form these like second order effects of an unhealthy attachment or privacy risks from getting too close or trusting an LLM too much if you feel like you have that close interpersonal relationship. I think there's a lot of a risk of us as humans becoming kind of susceptible to being socially hacked. So through interpersonal relationships, we form these unhealthy attachments. And similarly, many participants wanted a model that kind of very closely ascribed to their values or ideology and didn't provide any cross-cutting information. And again, that seems perfectly okay. Like maybe personalized value alignment is having a model and having the ability to have a model that's so closely tied to my values or ideology. But there are damaging impacts on that kind of at society at large, possibly to do with echo chambers or just increased confirmation bias. People are quite worried that one of the features of RLHF is that it can push models towards being more sycophantic, but it might also be the case that people kind of are looking for a sycophantic model, which makes the whole question even more complicated. The other takeaway is that my preferences as an individual might contravene or be at odds with your preferences as another individual acting in this wider system. So we found that some people really wanted an LLM that was like anti-woke. They hated neutrality. It really pissed them off. They wanted an LLM that always kind of fought a side in a debate. And other people wanted an LLM that never engaged, and they were horrified that an AI would show kind of any sort of bias towards either side of a really heated or controversial debate. So how do we satisfy these two things at once? This is not just a question of an LLM trying to portray lots of different viewpoints. It's kind of at a higher level than that. It's whether people want multiple viewpoints portrayed in the first place. And I don't think we can always assume that neutrality is something that people want in their LLMs. So the moral of the story, I think, is that you maybe can't always get what you want, or it's at least a lot more complicated to actually give people what they want. And it requires some thinking, some ethical thinking, some technical thinking about what it would mean to just give people a model that they prefer. So revisiting the alignment problem, in the early days, the alignment problem was quite simply specified as getting an AI to do what we want. And this definition has kind of been around since the very, very early days of AI. So Norbert Wiener, one of kind of the founding fathers of AI, he uses the term "we" a lot in this statement. We had better be sure that the purpose put into machines is the purpose that we really desire. And this idea is kind of, it's a bit cloudy with this common sense of we. So Stuart Russell, who also ran that Berkeley lab back in the day, still does, has this statement that machines can and will make better decisions than humans, but only when the values are aligned with those of the human race. Well, using empirical data shows us that both of these statements are quite hard to kind of operationalize in practice, because what do we as the human race want? I think one of the most important issues is not just getting AIs to follow a set of preferences, given we have specified those preferences already, but also in deciding which preferences, beliefs, and values LLMs should be aligned with, so more of the normative side of alignment. And ultimately, this should question is more of a question of power and representation, because by asking which, we're also asking whose, because as we've shown empirically, and is kind of common sense, different groups and individuals do hold different preferences, sometimes preferences that can't be reconciled with one another, and they're not all currently represented in model development. So this is also from a recent paper, which you can find online, where we talk about personalization as possibly a solution that resolves some of this tension in giving people what they want. What would be the consequences of just building a model on people's preferences and giving them this model that they prefer? So thank you so much for having me. There's tons more in the paper. There's some very long appendices that nearly killed me writing them. So I hope someone is going to read them at some point. But there's a lot of detail in them. And yeah, you can download the data today. It's on Hugging Face, it's on GitHub. All the code is on GitHub as well. We'd love people to start using it, and always happy to chat about different use cases.
Thank you. That was very interesting work. Looks like we already have someone raising their hand for a question, so we could probably start taking questions. Arena, do you want to go?
Yeah, can you hear me okay?
Yep.
Yes, thank you, Hannah. I thought your presentation was really interesting. I was really intrigued by the kind of conflict between values and then operationalizing them. At the beginning, you mentioned how you see a shift towards personalized LLMs, particularly like Apple's semantic context kind of proposition that they'll be like integrating your personal knowledge into your personalized LLM. And then at the end, you talk about whether or not that's a good idea and whether that would create things like filter bubbles. And I guess my question is how teams like that make these personalization decisions from the engineering side at places like Apple could potentially like use the insights of your research or the conclusions from it and actually operationalize those into the way that those personalized LLMs get created. Because I think that it's known, but I feel like it's hard to know how to do a trade-off, like how to make that trade-off between like giving the user what they want from this personalized LLM, but then not putting them into a state kind of like in social media, what has been seen in social media networks, where you only see the content you want to see. So I guess I'm curious about your thoughts on that.
Yeah, sure. So actually in the paper, this paper here, we kind of talk kind of precisely about this of like, given personalization is coming and is already here, arguably, what are kind of the attributes that we expect to be personalized and which ones do we think will kind of be banned or be outside the bounds of what either companies or regulators perceive to be legitimate personalization. So to break that down, I think when a team like Apple is deciding how to permit parts of their technology to be personalizable, I think there's a number of interacting factors. So there's things that will already just be like totally out of the remit of what can be personalized because they contravene some kind of national, international, supranational law or rights framework, right? So I don't think it's ever going to be possible to personalize a model that produces like, well, apart from maybe on the dark web, but that personalizes like child abuse material or something, right? There are some things where it's just like, no, you can't have that. Like, even if you want that preference, like we've already specified in society that that's like not an okay preference to have. And then there's some more kind of, so that cuts out like a whole section of potentially things that models would be capable of doing just because they probably are already regulated against in existing frameworks. Once we zoom down a bit more into things that are outside that, a bit more in the gray area, I think that's when it will start to come down to organizational principles, actually. So we saw this a lot in social media, that the kind of public agora was very much controlled by the terms and conditions of different organizations. So Meta has a slightly different terms and service than X, than Reddit, than 4chan. Those are kind of like a variety of how liberal people are in allowing different perspectives on their platform. And I think personalization will very much see that same trend, that there are things that are definitely not illegal, but sit outside kind of the risk surface of what OpenAI or Apple would want their users to use the system for. And that's at the moment where we're seeing a lot of kind of generic refusals. So it's like people wanting to have models communicate something offensive or tell them how to do something dangerous. Once we get past those organizational principles, I think what's kind of left as remaining is what we call this like zone of personalized alignment. And I think within that, it will be up to the users. So I think potentially there's parts of our data set. I mean, all of our data set was collected with like out of the box LLMs. So a lot of the time they will refuse dangerous or offensive requests because they're not kind of like fresh LLMs. They've already got these safety priors and alignment perspectives tuned into them. But I think we did still see people actually requesting quite like offensive content. Like when you ask people, when you say to people like there are no wrong or right answers and you encourage them to lean into controversy, you like kind of inevitably get people discussing like some hateful stuff. So our data set actually has less hateful content than some other large human feedback data sets out there, but it also does contain some hateful stuff. So I think maybe teams can use our data set to kind of work out what these bounds of personalization are. And I think once those bounds are kind of set, I don't want to necessarily speculate technologically how easy or hard that is. It's probably a pretty hard thing given how flexible LLMs are to being jailbroken and stuff. But I think that's the place where they could really look at kind of organizationally, how comfortable are we with these different requests to personalization from the user.
Thanks. That makes a lot of sense. And I think it's definitely a question as an engineer that you weigh without necessarily the resources to know what the rest of the human race thinks. I think that's a huge value in a data set like this, is having some justification and a data set to actually make that justification with. I can see teams, using this data set as a way to kind of validate what they're deciding in their organizational principles on potentially the preferences of a wider spread of people. So I appreciate the contribution.
Yeah, you hit the nail on the head there. That's exactly what we wanted to measure. We wanted to kind of throw out all the guidelines, all the organizational principles that end up kind of like contaminating a lot of the other human feedback data sets out there, like the Anthropic one or some of the ones before that, and just say, okay, like, tell us what you think. Some of that stuff probably isn't great. Some of it's really interesting. Some of it's definitely like very easily personalizable. You kind of get the whole spectrum.
Looks like we have one more question. AJ, do you want to go?
Yes. Hi. Thank you for the presentation. That was fantastic. Super interesting. I have what I think might be a fairly basic question, but it's something that I've been stuck on in my own research and just like, developing up my understanding of these tools. Like when we talk about personalization or, adaptation or alignment, well, to a lesser extent alignment, but personalization in particular, like mechanically and at the lowest levels, like how exactly do we know if something is personalized, quote unquote, and like how are people like measuring and understanding, the changes that happen when a model goes from, maybe like it's on the shelf, then you take it off the shelf, then you fine tune it or personalize it or adapt it to a particular user. Like, what is the exact change that's happening? Like, because I just like, I don't know, I find this topic interesting, but I do wonder like what, like, are we kind of like missing some of these like details in these conversations? So I was just wondering if you have any thoughts on that. Thank you.
Yeah, so since we actually first wrote this paper, which we released in March last year, and a lot has changed since then, there are actually now a couple papers that kind of approach technical solutions to personalization, and they vary in kind of how involved they are. So I do think you can get a long way nowadays, given how steerable LLMs are, just through prompt-based personalization. So we're trying something out at the moment using the PRISM dataset, which is essentially kind of what I would call like iterative prompt personalization. So just like, it's a very cheap way to personalize because you're not having to like fine tune or update any of the representations. You're just like condensing someone's profile or someone's repeated interaction into a prompt that goes back into the context of the model. So every time it gets a new prompt, it kind of has the history on that individual. And that would be like a very cheap way to personalize. I think if you had a lot of data on someone, you could do some sort of like parameter efficient fine tuning, but it's unclear to me how much data you would need and whether that's then just like a huge onus to collect from participants. I mean, OpenAI, obviously, like all the big companies obviously have enough data to do this, but like me as an individual with this data set, we have like 6 conversations on each individual. That is nowhere near enough to have like kind of any fine tuning effect. So the only way I could think to use that data would be to do some like constitutional AI or to like somehow used the seed of human examples to create a synthetic data set, which was larger. So these are all kind of methodological approaches to personalization. I think that various degrees of involvement, various degrees of data requirement. In terms of how do we know something is personalized, I think it depends on whether you're talking about kind of preference personalization or knowledge personalization. It's already possible in ChatGPT to kind of upload memory about yourself. So that would be, you could say like, oh, here are some facts about myself. I live in the UK, or let's say I live in Oxford, UK. And then if you're like using that model in conversations days from now, and I say, what's the weather like? The model will immediately know to initialize a RAG that goes and only looks at Oxford weather and not weather in San Francisco. So that's a way that you could know that a model is personalized. Or you could set it up as a predictive task. So that's one of the things that we're interested to see if people do with PRISM, is essentially to take a held out part of the data set and say, like, given a profile or given some sort of information about an individual, how accurately can you predict which output they would have chosen in this setting? And how well your model does is kind of a signal of how well it's personalized to the preference of that user. In a bit more of a fluid way, you could even just look at, if you have a personalized model and a non-personalized model, you could look at the outputs and see like the KL divergence in those two models of whether like the token distributions or the way that the model is actually generating tokens has somehow changed by conditioning it with some extra information about an individual.
Awesome. Thank you so much.
No worries.
Yeah, so we're at time. It looks like we have one more question. Hannah, if you have like 5 minutes to spare, we could go ahead. Otherwise, I can also ask him to email you.
Yeah, I can take one more.
Okay, Praveen, do you want to go? Praveen, if you're talking, we can't hear you.
Sorry, my mute button was on. Sorry about that. Hi, Anna. Thank you for the presentation. It was very insightful. I had 2 questions. One, when you find an alignment issue, do you target the training data set or do you target the model parameters to avoid future problems or issues?
Yeah, so this is a pretty hot topic right now, and I would say there's a couple different schools of people approaching alignment issues. One of the big schools is like McIntyre, which looks at exactly this of like having not changed the data, how do we kind of change the model internals to change how the model is processing inputs to outputs? Yes. And this is quite an important area precisely because models are big and data is expensive. And so you almost want to be able to find a way to more precisely tune how the model is working like a function so that you can do that on the fly without necessarily having to retrain or to collect a lot of data. I would say so far the approach, like the dominance of RLHF, has actually been an incredibly data-centric. I mean, apart from all the scaffolding that kind of already existed, the algorithm that you're using, whether that's PPO or DPO reinforced, the kind of star of the show in RLHF is actually the data. So a lot of kind of steerability or safety of models has been influenced by just collecting a large amount of human preference data. And it was actually one of the things that was released in the Llama 3 report was just how important this human preference data was for making the model better and safer. So data has been king for a couple of years, but I think there's been a big kind of growth in people finding these really smart methods to change the way that models behave based on kind of changing the fundamentals about the models or changing the weights in a way that's quite light or computationally efficient, ideally, so that they can be applied without having to retrain the model. And maybe people argue that data is quite a blunt tool to fix these behaviors. We don't know yet how well RLHF generalizes to kind of new data distributions that were quite different to what was seen during training. Whereas a lot of the McIntyre work like tries to make these changes in a robust way so that it's not like sticking a plaster on the wound. It's actually like sewing up that wound in a way that's kind of a bit more reliable. So I would encourage you to look up the Mech and Turt literature as well as ways to fix alignment through kind of model interventions as an alternative to this quite data-centric framework, which I tend to operate in.
Understood. Thank you for that. And how does it essentially, if new data comes in, the majority class will still be the alignment holding preference data?
Say that one more time.
If new data comes in after the model has been trained and then produced, and then new data comes in and there's model training on the new data, the alignment preference data would still be the majority class in comparison to the new data that's coming in. Basically, if society goes bad, and we get lots more of misalignment data as compared to the synthetic data that was provided during the model training, how do you monitor it? Basically, like, how does that work then?
Oh, interesting. I mean, yeah, I think so. Especially in some of the early RLHF papers, they kind of experimented with more like online RLHF versus like batch retraining of the model, where you would like collect a lot more data and then retrain, and then collect a lot more data and retrain. So I think there's the Ziegler paper from 2019 that talks about this. And from my memory, I haven't read that paper for a while, so I'd recommend going to the source instead of taking my word for it. But I think they find that the online training was quite unstable. So I think in this case, where you've got like lots of data coming in, let's say you've got a model that's live, that's being hosted, you put it online, and everyone starts using it for really nefarious purposes or to produce really harmful content, and you get a lot of this kind of like misaligned data, or they find a way to jailbreak. I think, I mean, I'm not an expert on actually how kind of operations work in the back end, but I think probably it's ideal to have some sort of filter about the model that is going, the data that is going into reward model training. And that's one of the things that we talk about in our data set as well, is like, I hope that people are not just going to use like all of this data willy-nilly, because there's actually like some stuff in there, like I mentioned before, that is potentially hateful or offensive. So I think it requires some like good data practices in terms of like filtering, having like a filtering step, some kind of classifier, whatever, before going into necessarily training the reward model, so that we can denoise and be a bit more sure of what we're actually teaching that reward model. I think a lot of the time at the moment, reward modeling is very collapsed, and there's a lot of hidden context, and that tends to be a bad thing.
Thank you. That was great. Thank you.
No worries.
Yeah, thanks, Hannah, for taking the time today. That was a very insightful talk, and I'm sure we all have learned a lot today. Thank you, everyone, for attending as well.
Thanks, everyone.
Bye.